Learning outcomes. After studying this module, you shall be able to know about the derivatives of opium, the toxikinetics of opiates, the therapeutic dose, fatal dose and the fatal period in case of opium poisoning. You will also come to know the forensic examination for detection of opiates. Introduction to the opium derivatives. Opium and all its preparation are true narcotics. Opium contains a large number of definite, highly complex crystalline principles, majority of which are alkaloids. About 40 alkaloids have so far been isolated, out of which morphine, codeine, thebaine, noscapine and papaverine are the main. The first three alkaloids are covered under the Narcotics, Drugs and Psychotropic Substance Act 1985. Morphine is the alkaloid which determine the identity and quality of opium. It should be more than 0.2% in the sample to be considered as opium, since it is obtained from natural plant. The amount of these alkaloids may vary from crop to crop and area to area. The alkaloids ranges from, like the morphine, it is 4 to 25%, codeine it's 0.7 to 3%, thebaine it's 0.2 to 1%, papaverine it's 0.5 to 1.3%, nicotine 2 to 8%. Basically, alkaloids obtained from opium falls into two main categories, the phenanthrene group and isoquinoline group. Phenanthrene group consists of morphine, codeine and thebaine, and isoquinoline group consists of papaverine and noscapine or norcotin and noscapine. Apart from these natural derivatives, there are several other drugs used in pharmacotherapeutics which are either semi-synthetic or synthetic analogues. Examples of other derivatives include alphentyl hydrochloride, alpha-podine, aniline hydrochloride, diphenylamine, etheroheptazine, ketobomidine, metazenol hydrochloride, methylfentanyl, pholcodine, remifentanil hydrochloride and sulfonyl citrate. Opiates have tremendous pharmacological importance and are used for various therapeutic purposes. Pharmacological uses of opiates. Derivatives, nature, classification, use, like bupropion, butyrophenol, codeine, dextromethorphan, diphenooxylate, phenylethyl, heroin, hydrocodone, hydromorphone, levorphenol, loperamide, methadone, morphine, nalbuphine, nalmefene, naloxone, naltrexone, oxycodone, oxymorphone, pregoric, pentazocine, pethidine, profoxyphene, tramadol. The nature, classification and use of these derivatives are mentioned in the table. Now next is major opiates like morphine. Morphine is a chief alkaloid of opium and occurs in the form of colorless, shining crystal having a bitter taste. The melting point of the crystals is 230 degrees Celsius. Morphine is the most generally used narcotic analgesic, that is the pain reliever. It acts as both stimulants and depressant, the central nervous system, that is the CNS. It induces a state of relaxation and happiness, that is euphoria, or sometimes sickness. Morphine, like other opiates, has a tendency to produce constipation, slow heart action, constriction of pupils, nausea and vomiting. The molecular structure of morphine you can see. Next is the codeine. Codeine or methylmorphine is an alkaloid of opium, which is prepared from morphine by methylation. It contains similar properties to morphine, but it is only 1/6 as effective as morphine. It is widely used as analgesic, antitussive and antidiarrheal agent in a dose of 10 to 60 mg of codeine phosphate orally. The structure of codeine you can see. Next is heroin. Heroin or diacetylmorphine is obtained by the acetylization of morphine. It was first prepared by Mary's Hospital in London. It is a white odorless crystalline powder with bitter taste. It resembles morphine in physiological action but is 3 times more potent than morphine and has been described as dangerous drug. Like morphine and other opiates, it is also taken orally, or sometimes it can be injected or inhaled. It induces depression and reduction in sexual urge, hunger and aggressive drives. Heroin itself is not an active drug, but when introduced into the body, it gets converted into morphine. Heroin completely transformed to morphine through first pass metabolism resulted in diacetylization when ingested. You can see the molecular structure of heroin. Now let us learn about toxicokinetics of opiates. By and large, most of the opiates are readily absorbed from the gastrointestinal tract and also can be administered by subcutaneous, intramuscular or intravenous injections. On the other hand, the effect of an oral dose is usually much less than that obtained on parenteral administration due to substantial first pass metabolism in the liver. For example, the bioavailability of oral morphine is merely 25%. Amount of protein binding is variable dependent on the nature of the opiates and fluctuate from codeine, that is 7%, to buropyridine, that is 96%. Morphine shows protein binding to the extent of 34%. Phytanosin, phythidine to 4 hours, morphine, codeine, heroin, or 8 hours, methadone, buprenorphine, fentanyl, alfentanil and sulfatanil are ultra short acting, that is around few minutes to 1 hour. Next is therapeutic dose and the fatal dose. let us understand what is therapeutic dose. It is the measured quantity of a substance, here it is drug, which is approved by the concerned authority and which can be used for remedial purposes for the sake of medical science, is known as the therapeutic or medicinal dose. Next, we have to understand what is the fatal dose. It is the minimum quantity of the substance, here it is drug, which if administered in the body by inhalation, ingation, injection or absorption is sufficient to cause death, is known as fatal dose. Now dear student, let us see the doses of various opiates, opium derivatives and the therapeutic dose as well as fatal dose. Like we have the crude opium. The fatal dose for crude opium is 500 mg. Next we have morphine. The therapeutic dose of morphine is 10 to 15 mg, whereas its fatal dose is 200 mg. Next we have codeine. The therapeutic dose for codeine is 10 to 60 mg, whereas fatal dose for codeine is 800 mg. Next we have the heroin. The fatal dose for heroin is 50 mg. Next we have pethidine. Pethidine has the therapeutic dose of 50 to 150 mg, whereas the fatal dose of pethidine is only 1 gram. Next is methadone. The therapeutic dose for methadone is 5 to 10 mg and its fatal dose is 100 mg. Next is the pentazine. The pentazine has the fatal dose of 300 mg, whereas its therapeutic dose, or you can say the medicinal dose, is 30 to 60 mg. Next is propoxyphene. The propoxyphene has the therapeutic dose of 100 to 150 mg and its fatal dose is only 1 gram. Next we have diphenyl oxalate, which has its therapeutic dose of 10 to 20 mg and fatal dose is 200 mg. Next we have the atropine. Atropine has the therapeutic dose 0.03 to 0.12 mg. And the last, hydrocodone. Hydrocodone has the therapeutic dose, or again medicinal dose, 100 mg. Now, let us learn about the forensic analysis of opiate derivatives. First is the chemical analysis. There are various presumptive tests for the detection of opiates in biological and non-biological matrices. Some of them like the Morris test. First, we have to prepare the Morris reagent. Take 8 to 10 drops of 40% of formaldehyde solution. Then it is added to the 10 ml of concentrated sulfuric acid. Now let us see the procedure. Small amount of suspected sample is taken in a test tube and about 10 drops of water is added. The moistened sample is then crushed with glass rod. The supernatant liquid of a sample is separated and few drops of same are placed on a spotting plate, followed by the addition of few drops of Marquis reagent. The development of purple-violet color indicates the presence of opium or crude morphine. Next is the Hussmann's test. Procedure: small quantity of dried extract is taken in a penicillin base. Then add 2 to 3 drops of concentrated sulfuric acid and heat it on a water bath for 30 minutes. Then the filtrate extract is taken in a test tube and moved over a flame for a few minutes until white fumes appear. If reddish or reddish brown or black color appears, it is cooled. 1 drop of concentrated nitric acid and crystal of potassium nitrate are added. A reddish violet color appears, which immediately changes to blood red and then to reddish yellow and finally fade away. Next is Faraday's test. First we have to prepare the Faraday's reagent. 0.5 gram of molybdic acid or sodium molybdate is dissolved in 10 ml of hot concentrated sulfuric acid. The resulting solution should be colorless. Now let us see the procedure. Dried residue of the extract is taken in a spot tile and few drops of Faraday's reagent are added to it. A violet color changing to green and finally blue gives the indication of presence of opium alkaloids. Now let us learn about the urotrophin test. Procedure: small quantity of dried extract is taken in a porcelain basin. Few drops of aqueous solution of urotrophin or hexamethylene tetramine is added and warmed slightly. A purple color changing to blue and then green is observed for positive indication of presence of opiate. Next is the Meckel's test. First we have to prepare the Meckel's reagent. 0.25 gram of salicylous acid is dissolved in 25 ml of concentrated sulfuric acid. Now let us see the procedure. Small quantity of suspected sample is taken on a spotting plate and few drops of Meckel's reagent are added. The appearance of deep green color indicates the presence of opium alkaloid. Next is the meconic acid test. Let us see the procedure. A neutral solution of ferric chloride is added to an aqueous extract of opium, gives a blood red which is not destroyed by boiling or by adding hydrochloric acid or mercuric chloride solution. Next is Dannings-Oliver test. Let us see the procedure. Extract of suspected sample is prepared in acetic acid and few drops are taken in penicillin base. 1 drop of ammonium hydroxide is added into the sample, followed by 2 drops of hydrogen peroxide. The resulting solution is stirred gently with a copper foil. Pink or wine red coloration gives the indication of opium presence. Codeine and deodorant do not respond to these tests. Now let us see the alkaloid and the resultant color in the various tests, that is the Marquis test, Meckel's test and Faraday's test. In the case of heroin, the purple-violet color appears in Marquis test, whereas Mac's test gives the dark green and Faraday's test gives the purple to grey purple. In case of morphine, there will be purple-violet in case of Marquis test, dark green in case of Meckel's test and purple to grey purple in case of Faraday's test. In case of codeine, there will be purple or violet color in Marquis test, green or blue color in Mac's test, and in Faraday's test it will be blue or green. In case of 6-acetylmorphine, purple violet color appears again in case of Marquis test and dark green color appears in case of Mac's test, and in case of the Faraday's test it will be yellow or green. Acetylcodeine gives the purple violet color in case of Marquis test, dark green and purple pallor in case of Meckel's and Faraday's test respectively. In case of papaverine, there will be no color appear in case of Marquis test, but dark blue and light green colors will be seen in case of Meckel's test and Faraday's test. And the last, noscapine, there will be bright yellow in case of Marquis test and green or blue color in case of Meckel's test and cherry red in case of Faraday's test. Now let us see the instrumental analysis. Confirmation of the presence of opiates requires high sensitivity and selectivity and is frequently carried out by various methods like the thin layer chromatography. The stationary phase for thin layer chromatography is activated silica gel with or without fluorescing substance. The TLC plates of 0.25 or 0.20 mm thickness. Then we have the mobile phase or solvent phase, system A, in which toluene, acetone, ethanol, concentrated ammonia in 45:45:7:3 ratio. Whereas in system B, ethyl acetate, methanol, concentrated ammonia will be 85:10:5 ratio. Next in system C, we have ethanol, chloroform, dioxane, petroleum ether, benzene, ammonium hydroxide, ethyl acetate in 5:10:50:15:10:15:5 ratio. In case of system D, ethanol, benzene, ammonium hydroxide and dioxane will be in 5:50:5:40 ratio. Now let us see the visualization methods, that is the ultraviolet light at 254 nanometer, drag and drop reagent spray, acidified potassium iodoplatinate reagent spray. Let us see the TLC visualization in case of various alkaloids with the reference of their UV fluorescence, iodoplatinate reagent and drag and drop reagent. In case of morphine, codeine, thibine, piperine, noscapine, heroin, the drag and drop reagent will show always the orange color, whereas the UV fluorescence is seen only in the case of piperine, noscapine and heroin, that is also blue. There will be no UV fluorescence in case of morphine, codeine, thibine. The iodoplatinate reagent will have different colors, like in case of morphine, codeine, heroin, it will give blue color, whereas in case of thebaine and papaverine, it gives brown color, and in case of noscapine, it gives purple color. Next is spectroscopic methods, that is the infrared Fourier transform infrared spectroscopy. The principal peak in KBR palette are morphine 805, 1243, 1118, 945, 1146 and 833. In case of codeine, 1052, 1268, 1500, 1111, 793 and 934. In case of thebaine, 1234, 1605, 1144, 1270, 1030 and 910. Now let us see the UV spectrophotometry. In case of morphine, aqueous acid at 298 nanometer and aqueous alkali at 298 nanometer. Then in codeine, aqueous acid at 285 nanometer and aqueous alkali will show no shift. In case of thebaine, aqueous alkali will show no shift, whereas aqueous acid at 284 nanometer. Now let us see the mass spectrometry. Principal peaks like morphine has 285, 162, 42, 215, 286, 124, 44, 284. In case of codeine, 299, 42, 162, 124, 229, 59, 369. In case of thebaine, 311, 255, 42, 44, 296, 310, 312 and 174. Besides above, following instrument analysis are also done for confirmation as well as for quantization of opiates like gas chromatography, high performance liquid chromatography, high performance thin layer chromatography, capillary electrophoresis, gas chromatography and mass spectrometry, Fourier transform infrared spectroscopy, that is FTIR. Now let us summarize what we have learned in this module. Opiates are among the commonest of the drug abused today in India. Heroin, which is also called to be brown sugar, is widespread among all classes of addicts in metropolitan cities of many countries. Opiates used for therapeutic purposes, example morphine, pethidine and pentazocine, are more commonly abused by medical persons. Buprenorphine is evolving as a major drug abuse even among non-medical personnel in recent times. Codeine, which is easily available over the counter in the form of antitussive preparations, is being increasingly abused, especially by college-going youths. Accidental deaths are not infrequent from overdose, particularly among intravenous abusers of heroin, that is, death of the needle. Suicidal deaths are also reported from time to time since opiates are reputed to cause painless death. Homicides are rare, but a few cases have been reported. Thank you.